Okay, so objects that move in simple harmonic motion will follow the basic like sine graph or cos graph, or a combination of the two, so the sum of the two graphs. So if you had x equals a sine nt, and I probably should put plus, because if there was a shift it would also work. It was plus alpha. And then there's a equals cos nt plus alpha. If you did it, if there was a combination of the two of them, let's say a sine nt plus alpha plus b cos nt plus alpha. Okay, now all of these motions oscillate about 0. So they oscillate about the origin. If you happen to put plus c on the end, then they would oscillate about c. So they're like, you've got time x, and if that's c up there, all that means is that, if it was a sine curve, they're just oscillating about c. The number in front here is called your amplitude, and that's how far above or below the center that it travels. So that would be c plus a, and below would be c minus a. Okay, and n, so n, that has to do with your period. So the period is equal to, because it's a sine or cos, 2 pi over n. Okay, so that means all the x values would be divided by n, and that would be your period. So like if you were looking at a normal, say, sine curve like this, see it goes from a to minus a, and the period is how long it takes to repeat itself. So that goes from 0 to pi to 2 pi, pi on 2, and 3 pi on 2. Now, the period is 2, if you have like x equals sine nt, and that's an a there, that's your amplitude, the period is 2 pi on n. All of the x values will be divided by n. So whatever the n is, that's what goes on the bottom of this here, and that actually shrinks it by n. If n was like, if it was sine 2t, that means it would go to be half as big, because it had 2 pi on 2, which would be pi. If it was sine instead of 2t, if it was t on 2, then it would actually dilate it and stretch it out, see, because that would be 2 pi and a half, which ends up being 4 pi. That means it's going to take 4 pi to actually do 1 revolution. So that's the basic displacement graph for something that is in simple harmonic motion. If you want to actually prove that it is in simple harmonic motion, then what you need to do is you need to differentiate it twice to get the acceleration. And once you've differentiated it twice to get its acceleration, for it to be in simple harmonic motion, x double dot equals minus n squared x minus c, where c is the center that it's oscillating about. So if the center was 0, then it'd be minus n squared x, and that's often what you see it as. This one here is the same thing, it's just with a shift. So let's just say you start with x equals a sine nt, and you want to prove that that is simple harmonic motion. So simple harmonic motion is basically when the particle oscillates about a central point. So it goes up and down, and it goes about a central point here. And what happens is it goes a, so it's going a above and a below, and it will always end up to be, so the acceleration is proportional by minus n squared to the displacement. So if you multiply by minus n squared x, that's actually the acceleration. This acceleration is proportional to the displacement. So let's start with this original graph here, this one, and let's differentiate it twice to get the acceleration, and let's just show that the acceleration can be written in terms of x. So if you get x dot I'm going to take the n out because that's the derivative of f dash times a. Now sine will go to cos nt. Okay, and then we're going to go again. So I'm going to differentiate again. So we're going to keep this n. Now cos will go to minus. So it'll be minus, and I'll take the n out, times a. It'll go to minus sine nt when you differentiate. So that's minus n squared times a sine nt. And then the sine nt, that is there, the a sine nt, that is this up here. So that is just equal to x. So it's minus n squared x. That's your acceleration. And that proves that it is in simple harmonic motion because the acceleration is proportional to the distance. Okay, and in the form of minus n squared x. Let's just look at one like, so we have a sine nt plus b cos nt, and let's prove this is in simple harmonic motion. Okay, so when we look at that then, we need to differentiate twice. There we go. All right, x dot equals, so I'm going to pull the n out because that's the do. Okay, so to prove that this is in simple harmonic motion, we differentiate the first time. The n comes out because that's the derivative of what's inside. The sine, you've got a is just a constant. Sine goes to cos nt. And then cos nt plus. And then we go n, because that's the derivative of what's inside. So it is n times. Now cos will go to minus sine nt. And let's not forget the b as well. Okay, so if you look at that, that's just a common factor of n. Sometimes it's actually good just to take that out. That's a cos nt minus b sine nt. So if you differentiate again, you get the second derivative. You get n, a, cos will go to n sine nt, but it'll be a negative, minus b times n cos nt. Okay, so the common factor there now, you notice that when you look at it, it is minus n. You've got minus n and n with that negative there. I'm going to take that out the front. So when I take that out front, I've got that n plus a minus n. So you get a sine nt left, plus, because I took the minus out, b cos nt. So that's minus n squared, a sine nt plus b cos nt. Now, basically, this whole part just here, the a sine nt, b cos nt, if you look back up to the top, that is equal to x. So we can now replace that with an x. So it's minus n squared x. Therefore, it is in simple harmonic motion, because the acceleration, which is x double dot, is in the form of minus n squared x, proportional to its displacement, x. Okay, so if we look at x equals 5 cos 3t4, to show that that is in simple harmonic motion, you differentiate once. The cos will go to minus sine, so it's 5 with a minus, and 3, because that's the derivative of what's inside, sine 3t, and the 4 will go to 0. Differentiate again, you get minus 5 times 3, sine will go to cos 3t, times the derivative, which is another 3. So if you look at the 3 and the 3, and you take that out the front, that's your minus n squared. So that's going to be minus 3 3s are 9 times 5 cos 3t. So just take the derivative and put it out the front. Take the derivative of what's inside, which is that n, because when you do that, what you have left here then, the 5 cos 3t, is the same as the 5 cos 3t up the front. So all that's left to do now is you bring the 4 to the other side, and you get x minus 4 equals 5 cos 3t. So So that means that you can replace, you got x double dot equals minus 9 times, and in place of the 5 plus 3t, you can put x minus 4. So therefore, it is simple harmonic motion because it is in the form of minus, in the form of acceleration, in the form of minus n squared x minus c. It's proportional to its displacement.